Module Overview. In an era defined by immersive environments, intelligent automation, and dynamic user interfaces, the role of color theory has expanded into augmented reality (AR), virtual reality (VR), artificial intelligence (AI), and responsive digital systems. This module provides a deep exploration into how color operates within these emerging technologies, transforming user experience, spatial interaction, psychological impact, and computational logic. Designers, developers, and technologists must now consider not just how color is perceived on a static 2D surface, but how it shifts in real time, responds to user interaction, adapts across environments, and integrates into machine learning processes. This module ties traditional color theory to cutting-edge platforms, preparing learners for the future of immersive and intelligent design. 1. Color in augmented reality. AR. 1. Nature of AR environments. AR overlays digital visuals on real-world environments via smartphones, tablets, or headsets. The color context constantly shifts based on lighting, surroundings, and movement. 2. Challenges of color in AR. Color blending issues. Virtual elements must stand out without clashing with the real-world background. Environmental lighting affects hue, saturation, and legibility. Designers must account for contrast dynamics, edge recognition, motion-based perception. 3. Solutions. Use adaptive color algorithms that adjust based on real-time light sensors. Implement depth-based gradients to distinguish layers. Apply AR color zoning for specific interaction hotspots. 2. Color theory in virtual reality, VR. 1. Psychological immersion, VR depends on color immersion to create presence and emotional realism. Color must support narrative depth, reinforce spatial orientation, prevent motion sickness. Color flickering and sharp contrasts can trigger discomfort. 2. VR design. Practices. Softer hues for background spaces to reduce fatigue. High contrast UI elements to float clearly in 3D space. Implement warm-cool transitions to indicate depth, distance, and interactivity. 3. Artificial intelligence and color algorithms. 1. AI and color recognition. AI models use computer vision to detect, classify, and enhance color. In facial recognition, object detection, scene understanding. 2. Color transfer and generation. AI-powered design tools, e.g. DAL, LE, Adobe Firefly, use color inference to auto-generate palettes, apply color styles, harmonize visuals based on prompts. 3. Bias in AI color usage. Skin tone classification biases can perpetuate racial inequality. Training datasets must include diverse color spectrums. Ethics of AI-generated color must consider cultural representation, inclusivity, and accuracy. 4. Dynamic and responsive color systems. 1. Real-time color adaptation. Websites and applications increasingly use dynamic theming, light/dark mode switching, adaptive backgrounds based on time or weather, mood-based UI color shifts, e.g. Spotify Canvas or AI chat apps. 2. Algorithmic color selection systems like Material Design 3 by Google enable dynamic color extraction from user photos, auto-theming via color tokens, CSS variables, JavaScript libraries, and AI APIs now drive color logic in real time. 3. Color personalization systems now personalize UI colors based on accessibility needs, emotion recognition, eye tracking. 5. Multi-device and multi-surface color rendering. 1. Cross-platform consistency. Colors appear differently on OLED versus LCD, iOS versus Android, AR glasses versus VR headsets. 2. Solutions use color profiles, sRGB, Display P3, Adobe RGB, apply media queries and breakpoints in CSS to adapt palettes, test across devices using simulators and real-world tools. 6. Experimental applications and future directions. 1. Brain-computer interface, BCI, and neural color projects now explore color stimulation through neural feedback. Example, EEG headsets adjusting color for therapeutic or focus-related tasks. 2. Quantum display coloration advancements in quantum dot technology produce wider, more accurate gamuts. Implications for ultra-realistic color in medical imaging, education, and remote work. 3. AI-driven emotional color forecasting. AI tools analyze user text, voice, or facial expression to adjust app color in real time. Emerging platforms include Emo Color API and effective computing engines.
Station 7 Practical Implementation Framework Step Action Tools Tech egy Color Profiling Adobe CC Figma XD2 AR VR Simulation Unity Unreal Engine 3 Responsive Coding CSS3 Tailwind React Made AI Palette Generation DALL E Canva AI Chroma 5 Testing Stack Shim Daltonism Chrome DevTools.
Module Summary. Color is no longer a passive property, it's an active, intelligent design agent. As we move into a future of mixed realities, AI-enhanced creativity, and data-driven personalization, the understanding of color theory must evolve. Designers who master this module will not only understand how to make visuals pleasing, but how to build systems that see, feel, and respond with color intelligently and inclusively. This advanced knowledge bridges art, science, and technology, ensuring that color design is not just beautiful, but dynamic, immersive, and human-centered across all dimensions.